put these two types of solutions together, what I'm going to do is I'm going to put a concentrated force here at this position, right, which is position D away from the left-hand side. It's a force of Q. Our force of P is still located here, and we're going to see how we can assemble these two together. So let's think about it before we do the mathcad solution. Let's think about it and assume what we're going to get. Right? So we can do the free body diagram as is shown right here. Right? The free body diagram for just this load. Right? So just this load. And we're going to have to superimpose that on top of the distributed load. Right? So it's essentially adding those two curves together. And if we do that, we can get a solution that looks something like this. So that's the two combined together, this distributed force spread across here, something like that. So let's look at the solution in mathcad. Solution in mathcad, I took the value of 10 meters, Q of B is equal to 400 newtons, and a distance of 2 meters for D, and I get the concentrated load, the 3-point bending that's asymmetrical in this case towards the left-hand side, and I get the shear force at this end and the shear force at this end, and it's constant all the way through, and it's constant all the way through here. From that, I can take the moments, and the moments are shown here. So I just took the moment, which is the integral of that once again, and I get straightforwardly this nice triangular shape, concentrated with the maximum at 2 meters. Now, I can then find the distributed force. In the distributed force, we're going to build up the solution as is shown here. Same thing, distance of 10, P is equal to 500 newtons, A is equal to 6, C is equal to 2, same as what we had before. So it's really the same solution. This V1 is exactly the same condition. Okay, and now I'm going to show V, V1, and the sum of these two all plotted together, and we're going to go through this step by step. So V was the initial load, and that's the what was red over here. So this is this one. Right, so we have that solution, and on top of that solution we have the one with a distributed force with the P load, which has been distributed across some distance, which is shown here, and then the sum of those comes out like this. So we add those together, and we get the inevitable solution. I'll highlight it in red this time. Oops. Something like that. So it's been highlighted in red. Okay. And then we can come along and find the moments. In this case, we can find the moments for, as we've done before, for this one, and for this one, we add the two together inside the integral, right? So it's just one function, one segmented function, complicated, but one segmented function. And then we go ahead and plot it, and here's our solution. Okay, so we have our distributed load with the rounded top on it, our concentrated load with the triangle, and then we add these two together, and we get, in the end, this solution with this rounded piece here, and then a straight section like that. So that's our solution that gives segmented, combined loads and shows how we can actually add together the shear force diagram and then integrate whatever that function is as our ultimate solution. Thank you very much.